Welcome to the deep dive. Ready to explore some seriously mind-bending ideas about evolution?
Always up for a challenge.
Excellent. Today we're diving into Richard Dawkins' The Selfish Gene.
Oh, a classic. And it's celebrating its 30th anniversary?
Yep, still sparking debate after all these years.
Well, it does challenge some pretty fundamental assumptions about how evolution works.
Right, like who's really calling the shots?
Exactly. Instead of focusing on individual organisms, Dawkins flips the script and puts genes in the spotlight.
So it's not survival of the fittest individual, but survival of the fittest gene.
You got it. Genes are the ultimate replicators, battling it out across generations to ensure their own survival.
Okay, I'm starting to see how this selfish label comes in. But doesn't that sound a bit harsh? Like genes are these tiny little villains plotting to take over the world?
Well, Dawkins clarifies that selfish doesn't mean genes are malicious or have conscious intentions. It's more about their inherent drive to replicate and spread.
So it's less about evil intent and more about the fundamental nature of these replicators.
Precisely. It's like a built-in imperative to keep those copies flowing.
So how does this play out in the real world? How do selfish genes actually influence the way organisms behave?
Well, think about worker bees in a hive. They dedicate their entire lives to raising the queen's offspring, sacrificing their own chance to reproduce. Seems incredibly selfless, right?
Yeah, the ultimate sacrifice for the good of the colony.
But from a gene's perspective, it makes perfect sense. Worker bees share a high proportion of genes with their siblings. So by helping raise more siblings, those worker bees are indirectly ensuring the survival and spread of their own genes.
Wow, that's fascinating. So even seemingly altruistic behavior can have a hidden layer of genetic self-interest driving it.
You're getting it. And this isn't just limited to bees. Kin selection is at play in all sorts of animal societies.
Okay, my mind is officially blown. So genes are these powerful forces shaping behavior behind the scenes, but how far does their reach extend?
Well, that's where things get even more mind-boggling. Dawkins introduces this concept of the extended phenotype. It's the idea that genes can influence not just the organism they inhabit, but the environment around them and even the bodies of other organisms.
Wait, genes can reach beyond their own bodies and manipulate the world around them. That sounds almost like science fiction.
It does, but it's backed up by some pretty amazing examples in nature.
Okay, I'm hooked. Give me one that really illustrates this extended phenotype idea.
How about a caddisfly larva? It constructs this intricate protective case around itself from pebbles, twigs, and other materials it finds in its environment.
So it's like a little architect designing its own home.
Exactly. But that case, built according to a genetically encoded blueprint, is essentially an extension of the larva's phenotype, providing camouflage and protection from predators.
So the genes are literally shaping the environment to enhance their own survival.
Precisely. It's like the genes are reaching out beyond the organism's physical body to shape the world in a way that benefits their own propagation.
And this extended phenotype idea applies to other species too.
Oh, absolutely. From the nests built by birds to the webs spun by spiders, genes are constantly shaping the world around them in ways that benefit their own survival.
Okay, I'm starting to see the bigger picture here. So if genes can manipulate their physical environment, can they also influence something as complex as human culture?
You're thinking like Dawkins. He proposes that human culture itself might be part of our extended phenotype, with ideas, beliefs, and behaviors acting as replicators in their own right.
Whoa, you're telling me our art, music, even our scientific theories could all be part of some grand genetic strategy?
It's a bold idea. Dawkins calls these cultural replicators memes.
So memes are like genes for culture.
Exactly. Catchy tunes, fashion trends, religious ideas, they're all memes competing for attention and replication in the vast landscape of human culture.
This is seriously blowing my mind. It's like there's a whole other level of evolution happening right before our eyes, shaping our minds and societies.
And it all goes back to those selfish genes, working their magic in ways we never imagined.
This is incredible. We're only in part one, and I already feel like I'm seeing the world in a whole new light. Where do we even go from here?
Well, next we can delve into those specific examples Dawkins uses to really bring these ideas to life. We'll explore the fascinating world of kin selection, the mind-boggling implications of the extended phenotype, and dive deeper into that intriguing nation of memes as cultural replicators.
Count me in. I can't wait to see where this deep dive takes us. All right, so we've established that genes are these incredible replicators, pulling the strings behind the scenes. But I'm still grappling with this idea of selfishness. Does that mean we're all inherently selfish, doomed to act in ways that benefit our genes, even at the expense of others?
That's a common misconception. It's important to remember that Dawkins isn't equating genetic selfishness with human selfishness. Genes don't have conscious intentions or moral compasses, right? They simply operate according to the principles of survival and replication.
So how do we reconcile the idea of selfish genes with the reality that humans often engage in acts of altruism, kindness, and self-sacrifice? It seems like a contradiction.
Not necessarily. Remember, genes can benefit from cooperation and altruism, especially when it comes to kin selection. Helping relatives, even at a personal cost, can increase the survival and propagation of shared genes.
So those seemingly selfless acts of helping family members might actually be driven by a deep-seated genetic logic.
Exactly. Think about a mother bird risking her life to protect her chicks from a predator. It seems heroic, but from a gene's perspective, it's a calculated risk to ensure the survival of copies of those genes in her offspring.
It's like those genes are whispering, protect those chicks, they carry our legacy.
Right, and this kin selection can extend beyond immediate family. Think about social insects, like ants and bees. The worker bees, who are all female, forego their own reproduction to help raise their queen's offspring.
And why would they do that? It seems like an evolutionary dead end.
It's because of a quirk in their genetic system. Female bees are more closely related to their sisters than they would be to their own offspring. So by helping raise a large brood of sisters, those worker bees are actually maximizing the spread of their own genes, even more effectively than if they reproduced themselves.
Wow, that's incredible. So what seems like self-sacrifice is actually a brilliant evolutionary strategy to ensure genetic success. It really makes you appreciate the power of these hidden genetic forces shaping behavior.
It's a reminder that evolution isn't always about competition and cutthroat individualism. Cooperation and even self-sacrifice can be powerful tools for genetic survival.
Okay, so kin selection explains a lot about altruism within families. But what about acts of kindness towards strangers, people we're not genetically related to?
That's where things get even more interesting. Dawkins explores the concept of reciprocal altruism, where cooperation can evolve even between unrelated individuals.
So how does that work? If genes are inherently selfish, why would they ever promote behavior that benefits someone who doesn't share those genes?
Think of it as a long-term investment. If I help you today, there's a chance you might help me tomorrow. It's a strategy that can pay off over time, especially in situations where individuals interact repeatedly.
It's like a you scratch my back, I'll scratch yours approach to survival.
Exactly. And Dawkins uses game theory, a mathematical framework for analyzing strategic decision-making, to explore how these seemingly selfless behaviors can evolve. He uses examples like the hawk and dove scenario to illustrate how different strategies can emerge and stabilize within a population, even if they involve cooperation or self-sacrifice.
So nature is running its own experiments with cooperation, testing out different strategies to see which ones lead to the greatest success over time.
Precisely. And that brings us to one of the most compelling and controversial ideas in The Selfish Gene, the concept of memes as cultural replicators.
Okay, this is the part where my brain starts to melt a little. We touched on this earlier, but I'm ready to dive deeper into the world of memes.
Remember, Dawkins defines a meme as a unit of cultural information that can be copied and transmitted from one mind to another. It could be a catchy tune, a fashion trend, a religious idea, a scientific theory, or even a simple gesture.
So those earworm songs that get stuck in your head, or those viral dance crazes that sweep the internet, those are examples of memes in action.
Exactly. And just like genes, memes compete for attention and replication. The ones that are most successful at spreading and replicating themselves become more prevalent in the meme pool, the vast ocean of human culture.
It's like a whole other level of evolution happening right before our eyes, with ideas and cultural trends battling it out for dominance.
Precisely. And Dawkins argues that the same principles of variation, selection, and replication that drive biological evolution also apply to the evolution of memes.
So those viral videos that spread like wildfire online, they're not just random occurrences. They're successful memes that have outcompeted their rivals in the vast landscape of the internet.
Exactly. The internet has become a breeding ground for memes, accelerating their spread and evolution in ways that were unimaginable just a few decades ago.
It's like the internet is a giant petri dish for cultural evolution. This is seriously mind-blowing stuff.
It is. And it raises all sorts of fascinating questions about the nature of human culture, the power of ideas, and the ways in which our minds are shaped by the information we encounter.
This is all incredibly thought-provoking, but I'm also feeling a little overwhelmed. It's like we're peeling back layers of reality, revealing these hidden forces that shape everything around us.
I know what you mean. The selfish gene challenges our assumptions and forces us to confront the complexity of life in a whole new way.
I can't wait to see where we go from here. So much to unpack. But this idea of the extended phenotype, genes shaping the world beyond their own bodies, it's really stuck with me. How far can that influence go?
It's a question that keeps scientists buzzing. Dawkins himself suggests that even human culture might be part of this extended phenotype.
So our music, our art, this conversation we're having, all extensions of our genes.
It's a fascinating thought, right? It really blurs the lines between what's natural and cultural. We're not just products of our genes, we're also actively shaping the world, which might, in turn, benefit those genes.
Like our genes are these puppet masters pulling strings across generations.
It's a powerful image. And there are so many amazing examples in nature that illustrate this. Remember those caddisfly larvae building their cases?
Oh yeah, like little architects?
Exactly. But think about this. A parasitic fluke that infects a snail.
Ugh, parasites. Not my favorite.
I hear you, but stick with me on this. These flukes need the snail to survive, right? But they also need it to be healthy enough to avoid predators.
So it's in the parasite's best interest to keep its host alive. Makes sense.
Right. But here's where it gets wild. These flukes can manipulate the thickness of the snail's shell.
Making it tougher.
You got it, making it more resistant to predators.
So the parasite is actually helping its host survive.
In a way, yes. It seems counterintuitive, but it makes sense from the fluke's perspective. By manipulating the snail's shell, the fluke's genes are indirectly protecting themselves.
It's like a twisted form of altruism. The parasite helps, but only because it benefits its own genes in the long run.
Precisely. And Dawkins argues that this extended phenotypic influence is everywhere in nature. Birds' nests, spider webs, it's all part of this grand genetic strategy.
It's mind-blowing. It's not just organisms struggling to survive. It's this intricate web of genetic influence playing out everywhere.
You're getting it. And that leads us to perhaps the most radical idea in the selfish gene. Human culture itself might be part of this extended phenotype.
Whoa, hold on. You're saying our music, art, even our civilization all come back to our genes trying to replicate.
It's a bold claim, right?
Mhm.
Dawkins says memes, those bits of cultural information that spread from person to person, are like replicators in their own right.
So those catchy songs, fashion trends, even those internet memes that go viral, they're all like genes for culture.
You got it. And they compete, just like genes, for attention and replication.
It's like there's another layer of evolution happening right in front of us, shaping our minds and societies.
Precisely. The selfish gene really shakes things up, doesn't it?
It definitely does. It's challenged so many of my assumptions about altruism, the environment, even culture. I feel like I'm seeing the world through a whole new lens.
That's the power of Dawkins' work. It pushes us to think differently, to consider these hidden forces shaping everything around us.
So where do we go from here? What's the takeaway for our listeners?
If you haven't already, pick up a copy of The Selfish Gene. It's a challenging read, but so rewarding.
Absolutely. And don't just take it at face value. Challenge the ideas, discuss them, and see where they take you.
And remember, just because our genes might be selfish, it doesn't mean we are. We have the power to choose, to cooperate, to build a better world.
Beautifully said. Thanks for joining us on this incredible journey into the world of the selfish gene. We hope it's inspired you to keep exploring these amazing ideas. Until next time, keep those brains buzzing.